Now let's have some fun. Let's look at using SPSS to do the analysis for us. So we're going to talk about quite a few of these, and we'll do a few of them in SPSS today. So here's a list of the ones that we've talked about. We're not going to do by serial because, well, at this point, it's really hard to find even any syntax to do by serial in SPSS. If I happen to find that in the next few weeks or before the end of the semester, I will share it with you. But what I had before is, anyway, it's just not working right now. So we'll have to find some new syntax that you can use for a biserial correlation. But what we are going to do is use SPSS to do all of these other correlations. So what I want to do is get out of the slideshow, and we'll kind of switch back and forth between this slide and SPSS, and we're going to try all of these. We're going to start with Pearson's correlation coefficient. So let's switch over to SPSS, and we said we were going to do, well, now we've lost our slide. That wasn't good. Let's go back down here. We're going to use the two variables FSP and FCB to run our analysis. All right, so back over here to our data. Let's move over to data view. We're going to do analyze, correlate, bivariate. I've done some other analysis, so we don't want to do that. What we want to do is FSP and FCB. All right, let's go back. FSP and FCB. FSP and FCB. All right, we highlight those two variables. We move them over. Notice that Pearson's is checked, two-tailed, and we want it to flag significant correlations. We say OK, and we get our result. I'll go ahead and tell you that your correlation is 0.41. We're going to round to 2 places after the decimal, and it is highly significant because the p-value, your significance value, which we're going to indicate as p, is less than 0.001, so highly significant. All right, let's look at what we're going to do next. Let's do Spearman's row. Remember, when we do Spearman's row, in this case, we're going to have one ordinal variable and one continuous variable. We're going to use FSP for our continuous and education for our ordinal. So that one's going to be easy also. FSP and education. So we go back, correlate, bivariate, FSP, and education. And this time we don't want Pearson's, we want Spearman's. So we changed where our check mark was, and we say okay. No problem. We've got a negative correlation this time, negative 0.02. No significance. See our p-value, 0.77. Okay, no relationship between education and their, I think that's their perception, their food safety perceptions. I think that's what FSP stands for. All right, let's see what's next. We're going to do Kendall's tau, age and education. So if we're doing Kendall's tau, 2 ordinal variables, that tells us age must be ordinal, right? Let's just confirm that. We'll go over here to variable view. We're going to scroll down and find age. There's our age variable. And look right here. If you click, you can see how the data were collected. And you can see that the ages were in categories. All right, so age and education. Is there a relationship between age and education? So let's get age moved over. And I believe we said we were going to do Kindles. I'm going to leave Spearman's checked because remember it said that we could use that as an option too for two ordinal variables. Let's just see if there's any difference in the output that we get. All right, parametric correlations. We've got Kindle's tau here. We've got Spearman's rho down here. The correlation when we use Kindle's tau is 0.325. And the correlation when we use Spearman's rho is 0.384. So there is a difference, right? We've got a difference in the correlation coefficient between education and age and education and age. Interesting, right? I'm not going to try to explain it right now. We'll come back to that at a later date. Just know that in either case, whichever one you've used, the significance value is highly significant. P is less than 0.001. All right, which one do we do next? We're going to do phi, which means we need two dichotomous variables. We're going to use the response to, do you drink raw milk, and are you a first-time mom? Both of those responses are yes, no. We're going to use those two variables for our analysis. All right, let's go do it. All right, we've got to get to phi. Wait, let's go back. Let's look at our little cheat sheet down here that says we go to Analyze Descriptive Statistics, Crosstabs, Statistics. Okay, now we know how to get there quickly. Analyze Descriptives, Crosstabs. Cheat sheets are always good things, right? Analyze Descriptives, Crosstabs. We could have used a lot of time looking for that. We're using Q2C, did you drink raw milk? And we're using, are you a first-time mom? Q13. We want to do phi and Kramer's V. And let's see what kind of relationship we get. All right. Look at that. So the correlation between the two, or the relationship between the two variables, is 0.07. The significance value, or the p-value, is 0.28. Not significant, right? Okay. No relationship between being a first-time mom and drinking raw milk. Good deal. Let's see what our next analysis is that we need to do. We're going to do point biserial, which means we need a discrete dichotomous variable and a continuous variable. So we're going to use first-time mom again in that food consumption behavior construct. All right, back to SPSS, point biserial. Here's an interesting thing to know. To do a point biserial correlation, it's really easier than you would think. Hold on, let me get the variables pulled over. First-time mom and food consumption behavior. Pull those over. There's no option for point biserial, right? It's okay, just use Pearson's R. So in SPSS, you use Pearson's R to do your point biserial correlation. You will, though, instead of saying R, which indicates Pearson's R, you will put R with a PB for point biserial, and the PB is in subscript in front of your correlation. So it would be R PB equals, well, let's see. In this case, it is negative 0.1 because we're going to round, and no significance. P equals 0.16. So no relationship between first-time mom and food consumption behavior. All right. Now we're going to do a rank biserial, And remember that rank by serial is a dichotomous and an ordinal variable. So we're going to use, again, the first-time mom, and we're going to use the ordinal variable of education. Stop and think about that one for a minute. There could be some relationship there if, say, people who have the higher degree delayed getting married and having children. So that's why something like that might be a legitimate question to ask. All right, so rank by serial, right? What if we don't remember how to do our analysis? Just going to look at our little cheat sheet that says, use Spearman's row. Okay, no problem. We're going to switch right on over there to SPSS. We're going to go to Analyze, Correlate by Variant. We're doing first-time mom and education level. We're going to change to Spearman's row, Spearman, right there. And is there a correlation? Well, correlation coefficient is 0.18, and it is significant. It is P equals 0.007. So because it's less than 0.05, in fact, in this case, it's less than 0.01, it is a significant relationship. All right, so just that quickly, we have demonstrated how to do all of those analyses. Here we go, back up. How to do all of those analyses in SPSS. All right, next slide. We've been reading and interpreting our output as we went along, right? And so let's just look at it one last time and make sure we're all on the same page. Where it says significance, SIG, two-tailed, that's your p-value. P is significance. What is your significance level? In this case, 0.0000, you would write as P is less than 0.001. And your R, and in fact, we can see that they did Kendall's tau on this one, right, is 0.33, because we're going to round. It was a positive correlation, by the way. Here's another example. In this particular example, they used Pearson's. The relationship between FSP and FCB is 0.41. The p-value, or the significance value, is less than 0.001. So we do have a significant positive relationship between those two continuous variables. All right. Now we can see that they're using Spearman's row, and we can see that the two variables are FCB, which I can tell you is food consumption behavior, and age. Since you're using Spearman's row, this tells you that one of these variables has to be ordinal. We know that food consumption behavior is going to be construct that has some items, so it's going to be continuous. So that tells you that age was collected in categories, or in ordinal response categories. All right, is there a relationship between these two? Yes, there is. In fact, it's a negative relationship, negative 0.19, and significance is P equals 0.005. So except for the case of P being less than 0.001, we're always going to tell what P equals. So P equals 0.005, or you could round it. In this case, I probably wouldn't. I'd just give the actual value. P equals 0.005. You know, we should talk about interpretation a little bit though. So as food consumption behavior goes in one direction, age goes in the other direction. We don't really know which one's going which way, but let's just say that as age goes up, food consumption behavior must go in the other direction of down. Or you could do it the other way and say as age goes down, food consumption behavior goes up. It's the same interpretation. Those people who are younger are going to have different food consumption behaviors than those people who are older. And you'd have to dig more into your data to understand better what those numbers were telling you. And then we have the case of, was someone aware of listeria, yes or no? The level of no. Were they aware of listeria? That was yes or no on that survey. And were they a first-time mom, yes or no? And the value here, the correlation coefficient is 0.076, and there was no significance because P equaled 0.267. No significance or no relationship between those two variables of awareness of listeria and first-time mom.